EOC review. We are going to go through and work this out together. If you have questions, you can ask me later on, but for now we're going to work straight through it. If you do need to go back and watch anything, you can always rewind and go back over anything, but I will answer questions later on if you have any after you've worked through this. Okay guys, here we go. So when we're multiplying these two problems, we need to write them using positive exponents. Currently we have a positive exponent and a negative exponent. We need to move the negative exponent to the opposite sides. The first thing I'm going to do is write it as a fraction. I'm going to work through alphabetically, so the a to the 2/3 is going to stay on the top as a to the 2/3. The b is going to need to move to the bottom of the fraction, and when we move it to the bottom of the fraction, it's going to become a positive exponent and be b to the 3rd. At that point, we no longer have any negative exponents. That's our final answer. On the next one, we need to go through and simplify as well using positive exponents. We have multiplication here. We need to deal with the numbers first. We would multiply the 4 times the 7 times the 9. When you multiply those all together, you get 252. Then you deal with the variables in alphabetical order. Now, x does not have any other like bases, so we're going to put the x to the second first and don't do anything to it. The y is going to go second, and when we deal with these like bases being multiplied, we add their exponents. And when we add 3 plus 9, that's going to give us y to the 12th. For the next one, to write something in scientific notation, you're going to need to move the decimal so that there is only one number in front of the decimal place. Do not forget when you're working on scientific notation that when you move to the left for the decimal point, you are going to have a positive exponent. When you move to the right with your decimal, you're going to have a negative exponent. Because as you move to the right, you make the number bigger, which means your exponent needs to make it smaller. It's like opposites. On this one, when you make the number over here and you make the number smaller by moving the decimal to the left, you've got to make the exponent bigger, positive. Okay, so here's your decimal place at the end of this number. To go to scientific, what's that word again? Scientific notation, you'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places, and we're going 9 places to the left. So we're going to need an exponent of 9 on our base 10 as our scientific notation, and it's going to be a positive number. So when we write this out, you're going to have that 3.463. You do not need to write all those zeros behind it. They do not change the value of it when you're doing a decimal behind that. Doesn't have a number after the zeros, so that's as far as you need to go. And we would multiply it by a base 10 with a positive power of 9 written on it. Okay. From there, for the next one, we need to put these in order. We're putting them in order from least to greatest. Now, in order to be able to compare them, we need to actually know what they are. So first thing we're going to do is transform these numbers into something that we compare. We're going to actually multiply them, see what it is that we need to do. So when we multiply these out, that 4.72 times 10 to the 5th power is going to put us at 472,000. That's what that number really is. The next one, 42.7 times 10 to the 2nd is going to put us at 4,270. The next one is just 472. I'm just going to carry it down. And for the next one, it's going to be 0.0427 times 10 to the 7th power, which is going to be 427,000. So these numbers are very similar. Okay, when we get to comparing least to greatest, we need to be careful about that. So out of these, this is the only one that is in the hundreds. So this is going to be our least. This is going to be number 1. So when I go to write it out, I'm going to write 472, always writing the original number. The second one is going to be in the thousands. That's going to be number 2. So when I go to write this out, it's going to be 42.7 times 10 to the second. For the next one, we've got to compare. Now listen, I'm going to line them up on top of each other. 472,000 versus 427,000. Go from this side over to the right and move to the left and compare as you go. These are the same. This one is smaller at this spot. Because of that, this one is going to be worth more or less. Well, can't do that. That shows you can't move from this side. That won't do it. You've got to start on the other end when you're trying to compare these. So when you look at these, you've actually got to start over here. It's 400,000. They're both 400,000, so those are the same. This one is 72,000. This one is 27,000. Of these, the 27,000, the 2 right here, is worth less than that 7. So this one is going to be our next because we're going least to greatest. So that's going to put me at 0.0427 times 10 to the 7th. And then our last one is going to be this one, the only one left, which is going to be 4.72 times 10 to the 5th. Now look, remember and notice that I did the original numbers back in order. I am not putting the numbers that I got when I multiplied them at the bottom in my list. It is the original numbers I'm putting in order. Okay, now to evaluate this problem, we're going to need to plug in x for that exponent. To do that, we're going to make a little table. For our table, we're going to set it up with our x over here. They've picked the numbers for x. They are 1, 2, and 3. We're going to put our equation right here, y equals 3 times 2 to the x. And then we are going to put our y's over here once we solve that. So when we look at this, it's going to be y equals 3 times 2 to the first, y equals 3 times 2 to the second, y equals 3 times 2 to the third. We would work each one of these out on a calculator. When you multiply this first one, it should give you 6. For the second one, that should give you 12. And then 2 to the third times 3 should give you 24. Again, don't forget, guys, for all of these ones that are involving powers, don't forget that we have that power button on our calculator that looks like this. It's got a y to the x. It lets you do any power on your calculator. Type the number, that button, and then the power, and it will give you the ability to do any power on your calculator when you're working these out. Now, remember that we're dealing with evaluating, so we're looking for this set of numbers for our answer. And it is a set of numbers, so we put braces around it, and it's going to go 6, 12, and 24. Okay. So for this next one, we are going to have to graph this exponential function. When we are dealing with graphing this exponential function, we've already been given a domain. So we're going to do something very similar to the one we just finished. We're going to be setting up a table. For this table, we're going to need a little bit more room because we've got a little bit more as far as the domain. We've got 5 elements of that domain. So we've got x over here. We've got the y equals 3 times 4 to the x. And over here, we're going to have our y's. The numbers we're plugging in are -2, -1, 0, 1, and 2. So I'm going to extend that down a little bit more just so we get plenty of room. So it's going to be y equals 3 times 4 to the -2, y equals 3 times 4 to the -1, y equals 3 times 4 to the 0, y equals 3 times 4 to the 1, and y equals 3 times 4 to the 2. Now guys, this is just calculator work. 3 times 4, power button 2, negative, equals. It will give you an answer in decimal form. When you type the first one out, it should give you 0.1875. The next one, when you type this one out, it's going to give you 0.75. The next one should give you, oh no, it should give you 3. For the next one, it should give you 12. And the last one is 48. Now, I strongly recommend that you don't just copy this, that you actually try typing these in the calculator, because if you can't type them on your own on the day of the day of the EOC, this is not going to help you at all. Okay, now let's go to graph them. So remember, X's tell you to go left or right, the Y's tell you to go up or down. So we're going to start off with that first order pair, which is -2, 1.875. So we're going to go over -2 and 1.1875. Sorry, 0.1875 is going to be just barely above that line. I mean, like, it's so close that it looks like it's almost touching it. Not quite touching it, but like right there. The next one is going to be -1, so you go to the left one and then up 3/4 of a block, 0.75 of the block, however you want to think of it. 75 out of 100, if we went up 100 for this one block, 75 would be 3/4 of the way up. 0 means don't go left or right, go up to 3. Oh, wait a minute. Did y'all see something? We have an issue. That's not really true. Look, go back. Do y'all see this? Ooh, this is such a good lesson to learn. Guys, look, 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 look. Do you see that the X's are numbered 0, 1, 2, 3, 4? And this is 0, -1, -2, -3, -4. But, -4. But the Y's are actually going by tens. And actually each block represents 5, so it's going to go 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and then 50 at the top. That's really important because your numbers get really big. But that means these are like microscopic differences. So this first one, when we go over to -2, 1.1875 is literally just about, I mean, I can't even probably make it small enough to be right there. 0.75 is just barely, I mean, you won't even be able to hardly tell the difference between those two, other than it's just a little bit taller because you go -1 to the left and then up a 0.75, and that's out of a total of 5 right there. So basically just under 1/5 of it. The next one is 0.3. Now, 0, don't go left or right. If we went and broke this up into 5 different pieces, think of it as 1, 2, 3, 4, and then 5 for the line. We want to go up 3 out of those 5. So I'm going to go up 3 out of those 5. So 1, 2, 3, approximately right there. The next one is 112, so we're going to go over 1 and up. There's 10, and then 11, 12, a little bit more. And then the last one is going to be over to the right 2 and up 48. Now I'm going to go up all the way to 45, and then 46, 47, 48. Okay, there's your exponential function. It's going to be graphed. So remember, when you're drawing this, which is really hard to do on this tablet, you've got to draw this where it does not actually go back up, but it also, I may actually use a tool to try to draw a line. It's very hard to draw on this thing, guys, so let's try using the tool to draw a line across here. There you go, where it gets closer and closer but never crosses it. It's so hard to draw on this thing that tiny. And then it's going to curve up very sharply as it goes up here. It's going to go through our points and make the curve. Oh, let me do it again. I'm close. So it's going to go to here, here, and then it's going to curve up sharper and sharper. At this point it goes very steep to go through this point way up here. And there we go. There's our exponential function. Now the function needs to be labeled y equals 3 times 4 to the x. Alright. Any questions on graphing exponentials, anything about plugging into exponentials, please let me know if you have any. Okay, solving some equations. We're going to solve these. We're rounding there's hundredth, which is 2 decimal places on either one of these. These are both solving and both rounded to 2 decimal places if we need to. So to solve this problem, we're going to start off by recognizing that it's a quadratic, but we do not have it equal to 0. So we're going to need to move everything to one side. So we are going to minus 7x, minus 7x. Notice there's no x term to subtract it from, so all we're doing is listing them in order from highest power down to lowest power. From there, we're going to try to do our diamond for this. This is a hard diamond. So we multiply the first number times the last number. That's going to give us 12 for the top of our diamond. On the bottom, you're going to end up with negative 7. The two numbers that multiply to give you 12 but add to give you negative 7 are going to be negative 3 and negative 4. So that's going to factor into 4x. Remember, you got to keep the number in front. The power divides by 2. So that's going to be 4x minus 3 and 4x minus 4. Here you're going to have to take a GCF out. Now remember, if it's a GCF for only part of it, it cancels out. If it was for the whole thing, we'd keep it in front. So this is going to come down without doing anything, the 4x minus 3. And on this side, we're going to divide both of these by 4, which means it's going to be x minus 1. Okay. At this point, we're going to solve both of these to get our answers. So on this one, it's going to be the opposite of negative 3, which is 3, divided by whatever number's in front of x, which is going to be 4. Now it says round, so we have to turn this into a decimal. So using your calculator, do 3 divided by 4. Once you divide that, it should give you the decimal form of 0.75, which is 2 numbers over, so we don't have to worry about doing anything to it. The opposite of negative 1 is going to be positive 1, and there's no number in front of x, so that's the final answer on that. So your 2 answers that you need for this problem are going to be, and remember, always go least to greatest when you're listing them in a set like this. It's going to be 0.75, comma 1. Those are your 2 solutions for that problem. Okay. For this next problem, we're going to do the same thing. We've got a square here. We're going to take and we are going to minus 100, minus 100. We are going to have 4x squared minus 100. No like terms to combine, so we just list them in order from highest power down to lowest. At this point, we want to take a GCF out. Since it is a GCF for the whole thing, it is going to stay out in front. That's going to leave us x squared minus 25. At this point, with 2 terms, there are only 2 things you can do. GCF, which we've already done, and difference of perfect squares. Since this is a difference, meaning it's subtraction, and these are both perfect squares, we are going to factor it into 2 sets of parentheses. One is going to be plus, one is going to be minus. That's what cancels out the middle terms. You take the square root of x, that goes at, square root of x squared, which is going to be x, that goes at the front of each of your parentheses. Then you take the square root of 25, which is going to put 5 at the back of each one of your parentheses. Now when you're solving this, the 4 does not affect your answer because 4 can never equal 0. So that part is out. The opposite of positive 5 is negative 5, and the opposite of negative 5 is going to be positive 5. When you go to put them in your braces, always list your negative first, then your positive. And there are your solutions. Okay, for the next one, it's asking us to determine whether it is making a linear, quadratic, or exponential equation out of these numbers in this table. So would it be linear? Would it be quadratic? Would it be exponential? Remember what the rules are. So if it's going to be linear, you would add the same number every time. If it is quadratic, you are going to multiply by the, exponential. Went out of order. Usually it goes exponential first. If it's exponential, you are going to multiply by the same number every time. And then if it's quadratic, this is kind of different. First of all, it's not going to show anything on the first level, so you have to go to the second level. And on the second level, you are going to add the same number every time. But that's only on the second level. First level will not have anything that's consistent. Okay, so we look at this. First of all, on the x side, it needs to be consistent across here. We look and see if this change is the same. That way we can use these models. This is going to be +1 every time. So when we look at this, it's a consistent change to our x, which means we can look at the comparison between our y's and see what's happening. We need to see if we're multiplying by the same number, adding the same number. What are we doing? Well, 3 plus, what would that take? That'd be +9. That's going to be +13. That's not the same thing. You're not adding the same thing every time. That's not going to work. Okay, so let's check multiplying by the same thing every time. What would you have to multiply by here? 3 times 4 would get you to 12. 12 times 4 would put you at 48. That's not going to work. It would skip 1. Nope, not that. Okay, so that means that we're looking for the second levels to be the same. So let's see what this first level does. Well, first of all, from here to here, you would have to add 9. From here to here, you would have to add 15. From here to here, you would have to add 21. And from here to here, you would have to add 27. Okay. So 9, 15, 21, 27. Nothing consistent in there. So let's check the second level. How much would you have to do for each one of these? Well, from 9 to 15, you would have to add 6. From 15 to 21, you would have to add 6. And from 21 to 27, you would have to add 6. So it is adding the same number every time on the second level, which is going to make it quadratic. Okay, last one on this front side. Let's knock this out. Let's see. A square picture frame occupies an area of 112. Well, first of all, area of a square, formula for that. Let's start with that. Area equals side squared. That's what we got to start with. So we know the area is going to be 112, and it wants to know the length of each side of the picture to the nearest tenth. Tenth is 1 decimal place. So we're going to replace that area right there with the 112 equals side squared. To undo a square, you are going to take the square root of that number. And when you take the square root of 112 and round it to 1 decimal place, that gives you 10.6 equals S. Now in this case it is units, so depending on how the test looks, it's going to be 10.6 feet. Okay. I don't know if that's going to be a drop down, whether you have to put the unit on it. There's all different kinds of things you can do on there. That's regular units though, because you're working backwards to get the side length. It is not area anymore, so the units are no longer square units. Okay guys, on to the back. So on the back side of this problem, on the back side of this worksheet, excuse me, we're going to go through and talk about what is the vertex of this equation. So first of all, guys, quadratic equation, pull out the A equals, in front of the X is a 1, the B equals, and that's in front of this here is going to be -4, and the C equals, the constant by itself is going to be -3. We're going to use the vertex formula, which is vertex equals the opposite of B all over 2A. So in this case, that's going to be the opposite of -4 all over 2 times 1. That's going to be the opposite of a negative. That actually turns into a, actually let's use different colors. That actually turns it into a positive. And then from there, that's going to be 4 over 2, which reduces down to 2. So the X part of your vertex is going to be 2. Alright, now remember your vertex is a point. 2 is going to be the x. We need to find the y. In order to find the y, we would need to do the plug-in to this equation. We're going to need to plug in 2 for x in the equation. So we're going to plug in to the x and write y equals 2 squared minus 4 times 2 minus 3. So that's going to be y equals, and if you type that into the calculator, 2 squared minus 4 times 2 minus 3 equals, that gives you a total of -7. So that is the y part of our vertex, which is going to be right here at -7. And remember, vertex is a point. You can't just get the x. You can't just use a vertex formula. That gives you the x part of your vertex. Then you got to plug it back in. That gives you the y part of your vertex. For the next one, you're finding the number of real solutions of this problem. Okay. So remember, that comes from the discriminant. The discriminant is going to be that b squared. Actually, let me write it over here so we can do our a, b, and c underneath it. The b squared minus 4ac. Okay. Whenever that discriminant, that number is going to be a positive number, you are going to have 2 solutions. Whenever that number is 0, you are going to have 1 solution. And whenever that discriminant is a negative, you are going to have 0 solutions. So let's see what it is in this case. So we'll pull out our a equals, next to the x squared term is our 3. Our b is going to be next to the x term, it's going to be -5. And our c is going to be the constant by itself, which is going to be 4. When we plug that into this formula, that's going to be b squared, so it's going to be -5 squared minus 4 times 3 times 4. When you work this out on the calculator, it's going to be 25, because a negative times a negative is a positive, minus, and then the second part of that is going to be 4 times 3 times 4. Actually, it's -4 times 3 times 4, which is going to be -48. When you do that subtraction, that's going to give you a total of -23. And since we have a negative discriminant, that means we are going to have 0 solutions. And guys, that's because you cannot have a negative number under the radical. And remember, this is the part that's under the radical in the quadratic formula. That's the part we're worried about. And you can't have a negative under that radical. Therefore, there are 0 solutions. Okay, for this next one, simplify, write the answer in standard form. This is just combining like terms. Whenever there is a plus between here, there's nothing to do other than combine like terms. We are going to be looking at the highest power, working down to the lowest, combining any that are alike. We have this 5x to the 4th. There's nothing to combine it with. We write it in front. We go to the x squared term, or excuse me, x to the 3rd terms next. But you have a -3x to the 3rd and a positive 3x to the 3rd. So they are actually going to cancel each other out. Then we go to the square term right here. It doesn't have anything to combine with, so we write -11x to the 2nd. And then finally, you're going to have your x terms. They're here and here. You're going to combine them, and 6 minus 8 is going to give you -2x. Remember, when you add and subtract, you do not change the exponents. Do not change the exponents when you're adding and subtracting like terms. There's nothing in between there. That was not multiplication. You're not distributing the negative. That is just plain old addition, which means you combine like terms. For the next one, you are using the distributive property to deal with this product. That means to multiply. So we are going to multiply the 3 times the 4. That's going to give us 12. And when we multiply like bases, we are going to add their exponents. This is like a 1 here when there's nothing written there. So 1 plus 4 is going to give us x to the 5th. Then the 3 times the -5 is going to be -15. And the x is going to give us x squared. That is already in standard form because it's already written from the highest power down to the lowest power, and that's where you would stop. Okay, for this next problem. Now guys, we could get all into writing the equation for it, doing all kinds of fancy stuff with this. We're not going to get into that. We didn't get into the vertex formula as far as writing the equation in vertex form, so we're not going to deal with that. I'm hopefully going to give you a way that you can possibly see this using that vertex form and kind of maybe be able to do it, because we didn't get to this in class. This is something that we get to when we teach with the honors. So, on your formula sheet, there is a formula for the quadratic function that looks like this. F of x equals a times x minus p and x minus q, where the p and the q represent your zeros. Okay, those are your zeros. Well, you have your zeros right here, so we need to plug those in. So it's going to be f of x equals, okay, and we're going to treat a like it's a 1, so it's going to cancel itself out. We're not going to deal with any fancy, we're not going to get crazy here, so we're just going to think of this like a 1 on the outside. That number can change the equation depending on what that number is. We're not going to get all into that for now, just think of it as a 1. Okay, unless they give you a point, you can use 1 there. Okay, and then the x minus your 0 right here, minus a negative 6 would turn it into plus 6. It's always the opposite because the formula has a minus in it. For the second part of it, it's going to be x, and again minus, and this is positive 5, so now it's going to be minus 5. Okay, so we need to go ahead and multiply the 1 across, but again, when you multiply 1, it doesn't change anything. That's just going to make it equal to x plus 6 times x minus 5. Right. And when you're at that point, you can go ahead and FOIL it. X times x is going to put you at x squared. X times negative 5 is going to put you at minus 5x. 6 times x is going to put you at plus 6x. And 6 times negative 5 is going to put you at negative 30. Okay. Now, we need a little more room to keep going. So we need to combine like terms. Going to make it f of x equals x squared plus x minus 30. We have our equation. Now guys, listen, your y-intercept is the second thing they want, so the y-intercept is going to be a point where the x is going to be equal to 0, and then there is going to be a number for y. It's the googly eyes, but it's the second part of the googly eyes. Okay? So when you do that in a quadratic, think about it. If we plug in f of, and we plug in 0 for x, that's going to be 0 squared plus 0 minus 30. So whenever you see this, 0 plus 0 minus 30 is going to put you at f of x is equal to negative 30. And remember, f of x just stands for y. It's another name for y. And that's going to put us at negative 30 for our y-intercept to that equation. Okay guys, let's keep going. The next one says factor the right side of the equation to find the zeros of the equation. So it's just a quadratic. We want to go through, we want to do our diamond and factor this out. When we do our diamond, it's going to be an easy diamond, so it's going to have negative 6 on the bottom, on the top, and 5 on the bottom. The two numbers that multiply to give you negative 6 but add to give you 5 are going to be 6 and 1. Remember, if the bottom's positive, you need the bigger number to be positive so that the 1 is your negative. So it's going to factor into y equals, and it's going to be x plus 6 and x minus 1. To find the zeros, you're just doing the opposite of whatever this is right here, and the opposite of this is going to be negative 6, and the opposite of this is going to be positive 1. Remember, solutions, they go in braces, negative 6, positive 1. There we go. Those are your zeros. Okay. Now, we got to get into another quadratic. We're going to be graphing this. Okay, to graph this quadratic, we are going to need to take out and do our A, our B, and our C. Our A is -1, our B is going to be -2, and our C is going to be equal to 1. Alright, we're going to need to use that vertex formula, which is the opposite of B all over 2A. That's going to be the opposite of -2 all over 2 times -1. Well, negative times a negative is a +2. And that's going to be -2. So that's going to be -1. So when we set up our table, and we're putting numbers in our table, that vertex is going to be in the middle. That's going to be -1. I'm going to go down above it. It's going to be -2, -3 for my x's. I'm going to go up on this side. It's going to be 0 and 1. This is going to be where my vertex is. I'm going to plug it into the opposite of x squared minus 2x plus 1. That's going to give me my y's. So when I write this out, it's going to be -1 times -3 squared minus 2 times -3 plus 1. That's going to be -1 times -2 squared minus 2 times -2 plus 1. Next one's going to be -1 times -1 squared minus 2 times -1 plus 1. -1 times 0 squared minus 2 times 0 plus 1. -1 times 1 squared minus 2 times 1 plus 1. As you work those out, again, pause the video, try working them out, see if you can get these answers. We got -2, 1, 2, 1, and -2. And remember, they are supposed to mirror each other on either side of that vertex. So to go graph this, the first ordered pair is -3 and -2, right here, to the left and down. The next one is -2, +1, so to the left and up. The vertex is going to be -1, +2, so the left 1 and up 2. The hardest one for people to get is the 0, 1, guys. 0 means don't go left or right, go up to 1. And look, it's got to mirror the other side, and it does. The last point is going to go 1 to the right and down 2. And that is your final point. You're going to draw your parabola by drawing in the curve on either side of this, extending it past the end of your graph. We're going to label it with y equals the opposite of x squared minus 2x plus 1. We're going to label the vertex right here, which is the ordered pair -1, 2. And the last thing we're going to put is this, x equals -1, as the line that it is going to reflect over, the axis of symmetry. So we're going to draw that as a dashed line right down here through the middle. And that is going to be labeled x equals -1. Okay, guys, last two problems. Now, we are solving a system, but the system is very different. The system is not going to be solved with 2 linear. This is 1 linear and 1 quadratic. We have not gotten to this yet. So this is kind of just a help in case they throw something like this at you. This is done in our Honors Algebra 1 courses, and we don't quite get to it. So I wanted to make sure you saw it before you took the EOC. So we are going to solve this one for y by minusing 7x from both sides. That's going to make it y equals the opposite of 7x plus 4. We're going to put a box around that now that we've solved for a variable. We are going to replace this y in this equation with what y is equal to over here. So it's now going to be -7x plus 4, that's where the y was, equals x squared minus 6x minus 8. Now to solve a quadratic, I need everything on one side and I need it equal to 0. So I'm going to go through and I'm going to add 7x, lining it up underneath its like term. That's going to make it 4 equals x squared plus x minus 8. Then I'm going to minus 4 minus 4. That's going to make it 0 equals x squared plus x minus 12. That's our diamond that we need to factor. So when we do our diamond here, that's going to put us at, let's see, negative 12 on top and 1 on the bottom. So it's going to be 3 and 4. Those are 1 apart. We need the bigger number to be positive because the bottom is positive. So we'll make our 3 the negative. So that's going to factor into x minus 3 and x plus 4. So our examples, our numbers, our zeros that are going to come out of that are going to be the opposite of this, which means it's going to be 3 and negative 4. That's our solutions, our zeros, whatever you want to call it. Now those are the x's. We're going to find the y's by plugging them back in. Okay? We have to solve it. We have to get full answers. So if we plug both of these back into the other equation, back into the one that's going to be the other equation. This one's the one we used here, so we're going to plug it back into this one. I'll plug it back into this one because it's easy, because it's already solved. That's going to give me my full ordered pairs. So I've got ordered pairs. Right now I have the x's. The x's right now are 3 and negative 4. I'm going to find the y's by plugging them back in. So that's going to make it y equals the opposite of 7 times, I'm going to plug in my 3 plus 4. That's going to make y equals negative 21 plus 4, which means it's going to be y equals 32. Sorry, wrong answer. It's going to be negative 17. Sorry about that. That's going to be negative 17. From there, the next one, when I plug it in, is going to be y equals. This time I'm going to be plugging in the other answer, which is the negative 4 plus 4. That's going to make it y equals negative 28 plus 4, which is going to, oh no, a negative times a negative is a positive. It's going to make it y equals 28 plus 4, which means y equals 32. Okay. Put our answers over here. For the 3, when we plugged it in, we got negative 17. And for the y, when we plugged it in, we got 32. Those are the 2 points where these two graphs are going to cross. Remember, this is a parabola crossing a linear equation, so it's going to cross it like that. It's going to hit in 2 places. Those are the 2 points where it crosses.